Yes, folks, welcome to the last discussion with 10 set of questions centered around algebraic expressions again for extended mathematics IGCSE. Without further ado, let's dive into the 10 questions. First problem, we are required to simplify 7a minus 3a. As we can see, the variable there is like, in other words, the degree is the same, it's a. So we simply look at the difference of the coefficient. 7 minus 3, it gives us 4. Then moving on to the expansion there, we are going to have 3 times 2x, it gives us 6x. Then 3 times negative 5, it gives us negative 15. I think that's what we have there. Then next is an expansion, and as we saw earlier, when we expanded the first two, they multiply themselves, giving us x squared, and the last term, 6 times 1, it gives us 6. Then on the middle part where we have like terms, we have 1 times x, that's x, 6 times x, that's 6x. So 6x plus x, it gives us 7x. I think that will be it for that expansion. Then next, we are interested in factorization, where we are looking for HCF of 9 and 18. It happens to be 9. Then I open my bracket. I use my HCF to divide 9x. The result is x. There's a plus there. 18 divided by 9, that's a 2. I think that's our factored form. Then next, we want to factorize x squared minus 9. So this is x squared minus 3 squared. And in this form, we build two brackets, because the process is called difference of two squares, where the signs are just different there. Then moving on to number 6, we are interested in simplification, where the x here, the degree is the same, they cancel, both numerator and denominator are the same. End up having 10 divided by 5, which is actually 2. Still moving, we have x squared plus 3x all over x. We want to simplify. So x is dividing both our numerator parts, so we can properly write it as x squared over x plus 3x over x. And according to laws of exponents, 1x will cancel, remain with x there, plus here the x's they cancel, that's 3. I think that's a simpler form of that given problem. Then looking at the next problem, we can see clear that our denominator is the same. And if it's the same, it becomes our common denominator, or the LCM itself. We simply simplify the numerators, which are made up of 1 plus 3, that's actually 4. But as we look into this problem, we're not done simplification, because we can see that 4 and 2, they have a highest common factor of 2 itself, which can simplify both numerator and denominator. And by doing so, we end up having 2 over x, because it's 4 divided by 2, it gives us 2. 2x divided by 2, it gives us x there. Then the next problem, we're interested in simplification of fractions where we are dividing. So here we have 6x over 5, but because we're dividing a fraction by a fraction, we turn the division sign to multiplication, and we bring in the reciprocal there, which happens to be x over 3. Then we test again diagonally, said we have things that can cancel. If we check carefully, there is 6 and 3, whose HCF is 3 itself. So when I divide the numerator there by 3, it gives me 2x times x all over 5 times 1 when I divide 3 by 3 there. And this will lead me to, when I say 2x times x, it gives me 2x squared all over 5. Then the last problem, we are interested in an explanation as to why factorization is important before simplification or simplifying algebraic fractions. So like we saw earlier, we can say diagonally or column-wise, some vectors can simplify, making the entire process quick and easy. So I think basically that's why factorization is quite important when we are simplifying algebraic fractions or expressions themselves. I think that's it for IGCSE extended mathematics, algebraic expressions, fractions, simplification, you name it. Please remember to like, share, and also subscribe to the channel to help the channel grow. Bye for now.